Myself, Dr. K. Viswanatah Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study what are some of the definitions and terminologies of a deflection of beams, which were covered in previous sessions. Now here, what is the deflection of the beam? Here, before going to study directly to what is the deflection of the beams, why deflection of beams are so important, what are the methods are required to find out the various deflections of the beams. Now here, let us study some of, types of beams and types of supports, so that we can understand better the deflection of the beams and their methods, why we have to study under various loads. So here, the most important thing is that let us begin with the types of beams. Types of beams. Let us recapitulate what are the types of beams. In the sessions of shear force and bending calculations, we discussed more about types of beams and how to draw the shear force and bending moment diagrams. There are various types of beams are there, but the prominent beams are here. Cantilever beam, number one is the cantilever beam, and the second one is simply supported beam. And the third one is overhanging beam. Simply supported beam and overhanging beam. Now here, how the cantilever beam and the beam is being supported by some supports. What are the types of supports? Then we'll come into again how the cantilever beam seems to be. What are the types of supports? There are various types of supports. The first support I'm going to consider, there are various types of supports. We'll see again how the supports are used for different types of beams. Now here, in the types of supports, number one is the roller support. Second case is the knife edge support. Third one is hinged support. And the fourth one is fixed support. So how these supports are being used for different types of beams. So here there are the three beams prominent we have studied. One more beam also. That beam is known as a fixed beam. Here it is the fixed beam. Consider for a cantilever beam, the cantilever beam is always with fixed support. The cantilever beam, if you consider the cantilever beam, the cantilever beam is always a fixed support. One end is free and another end is fixed. Here the cross section may be rectangular, the cross section of the beam is square or circular, whatever it may be. But one end of the beam should be fixed and another end is completely free. Then it is known as cantilever beam. You can take the example of your fingers. The fingers, all fingers, cantilever beams. One end is fixed and another ends are free. Okay, it is the design is different so that it is usable for all holding purpose. These are made of cantilever beams. Similarly here in the case of which support it is applied load. Now here cantilever connection, there's a fix. But in the case of the replica of the human being, the robots having fingers, the human robot, that those are also having fixed at one end and free. The next one is a simply supported beam. The simply supported beam is always supported with, the beam is supported with one edge is the knife edge hinged support, and another can become roller support. And there are various types here. One end is hinged support, and another one is knife edge support. Is the knife edge support. Again, the cross section of the beam can be either circular cross section or a square or rectangle or I section, C sections, and H section, Z sections, various. But the supports are being. Coming to next, in the case of overhanging beam, the overhanging beam will be, it is supported by, again, either hinged support or knife edge support, but one of the end is extended. There is extension to the left side. The same extension becomes to the right side also. To the right side also here hinged, it is knife edge. Or both sides can be extended also. Both sides can be extended. But the load is acting. Okay, these are the overhanging, these are the examples. I mean, how the overhanging beams. Another one is fixed beam. Fixed beam, both the ends are fixed. Both the ends are fixed. So here, in the case of cantilever beam, there is a fixed support. In the case of simply supported beam, hinged support and roller supports are here. There is no overextension. That's why it is a simply supported at the ends. The supported, it is a beam supported here. Then it is a simply supported beam. From your side, here it is a cantilever beam. It is a fixed cantilever, free at the other end. From your point of view, if you want to see, it is a fixed another side, but any one end, it is a free cantilever beam. Now both the ends, it is a simply supported beam. It is simply supported. Now again, it is a overhanging beam. Overhanged this portion. Next, this is also overhanging beam. From my side the left, from your side it becomes the right side. The left overhanging beam. Both sides overhanging. This is called overhanging beam. But simply support never have extension both the sides. It is simply support. Now what about fixed beam? It is the fixed beam. Exactly fixed completely. It is a fixed beam. The beam is fixed. Is a fixed beam example is the cantilever beam, and here it is overhanging beam, and one more is the simply supported beam. Now for supports, the reactions will be different. Suppose if the load is applied If the load is applied, point load, this type of load is known as a point load, or another name of point load is known as a concentrated load. Load is applied, there will be certain reactions will be developed inside the fixed portion. So what are the reactions are going to be developed? One is upward reaction, RV, vertically upwards. Another one is the downward horizontal reaction, RH. And the third one is the moment reaction for the case of fixed. In the case of simply supported beam, for a hinged support, here it is hinged support. Vertical reactions and horizontal reactions will be occurred. For a roller support, only one vertical reaction. Here it is again hinged support, vertical and horizontal reactions are to be considered in order to calculate the shear force and bending moment calculations. Here it is the knife edge support, only one reaction. For roller and a knife edge, only one reaction. For hinged support, this support is the hinged support. For two reactions, one is vertical, another one is horizontal. Now coming to overhanging beam, this is the knife edge support, vertical reaction. Here it is hinged support. One is vertical, any direction maybe. Now here horizontal. It is a hinged support, vertical and horizontal reaction. Here it is a knife edge support, vertical reaction. Knife edge support, vertical. Again here it is vertical and horizontal. Where is a fixed beam? Vertical, horizontal and reaction moment. Similarly, vertical, horizontal and another moment reaction. So in this we have studied the type of reactions, the types of beams and the types of supports. Okay, for calculating the shear force and bending moment calculations. Now here these are the things we have studied. These are the definitions. What are the cantilever beam and what is simply supported? What are the types of beams? There are various types of beams, but prominent types are cantilever beam, simply supported beam, overhanging beam, fixed beam. Now, when the load is applied, now we have studied coming to types of loads. For types of loads, here it is the concentrated load where W is acting. The symbolic presentation is that vertically downwards, action downwards on the beam, point load. Now if there is another type of load is known as the uniformly distributed load. This is called uniformly distributed load. That is represented as like a spring. It's like a spring we are keeping. This is the uniformly distributed load. It is small W Newton per meter length. Now if we consider there is another symbolic presentation of uniformly distributed load. This is known as what type of load? Here it is. That is uniformly distributed load. The uniformly distributed load can also be presented with a rectangle. That's why it is a rectangular load. Now another type of load is known as the triangular load. The triangular shape downwards. This is the triangular load. Another name of this load is also known as uniformly varying load, UVL. This is uniformly distributed load, UDL. It is a uniformly varying load, UVL. UDL and UVL. The same loads, it can become point loads. Now, for a beam, it is acting at the center. The point concentrated load at the exactly. It is from L by 2 distance. It is also from here L by 2. It is at the center. The overhanging, it is end A and length A. It is at the center, is acting at the centric load. It is a centric load. It is a centric load, not eccentric. Suppose if the point load, same point load is acting away from the center, away from the midpoint of the beam, then it is known as, what will happen? Then it is known as eccentric load. It is not at the center of the beam. It is at this eccentric load. In the case of simply supported beam, consider a simply supported beam. The load is acting away from the center. Or where? At the distance of A, and it is from B. Then this type of load, even though it is concentrated load, but it is acting eccentrically. That's an eccentric load. Now coming to, these are the types of loads. We have studied types of beams, types of reactions, and types of supports. What is the maximum deflection of a beam? What is the deflection first? Why deflection is so important? The deflection means when the load acts, consider a simply supported beam. When the point load is acting, after acting the point load, the beam will be deflected. Direction. This is the deflection of the beam. This deflection is known as, this is the bending of the beam. The beam will be bent in this direction. This distance is known as the deflection. If we consider the points at the supports, the support A and it is support B, and the point load is acting at C. So for the deflection curve, there is a tangent. If you draw a tangent, the angle between the original axis to the after tangential, that is known as the slope, theta A. With this is the tangent, this is theta B. Here, what is the slope here? What is the slope here? The slope is 0. That is theta equal to 0 at C. So where the slope is 0, the deflection occurred is known as the maximum deflection. Y becomes Y maximum. That is known as the maximum deflection. What is the maximum deflection of the beam? The maximum deflection of the beam occurs where the slope is 0. The slope of the beam, how to define the slope? The slope of the beam is defined as the angle between the deflected beam to the actual beam of the same point, at the same point. Angle between the deflected beam, yes. Angle between the deflection, this is the angle between the deflection, is the curve. But how can we find it at the point? We have to draw the fundamentals of mathematics, we have to draw the tangent. This curve and this axis, that angle is known as the slope. So how can we know this? What is the meaning? The slope makes here, when deflection occurs, then only slope comes into picture. But when the maximum deflection, the slope becomes 0 at the center load, at center point. The slope, what is the slope? The slope is 0, that's 0 degree, 0 radians here. In terms of angle and degrees, but while calculation, we use it for in the units of radians. Alright. Now that is known as the slope and the maximum deflection. This maximum deflection occurs where, for the case of a simply supported beam, when the concentrated load is at the midpoint of the point, when it is acting on the midpoint of the beam, where the maximum deflection occurs, there the slope is 0. Now, why deflection of the beams are important? The deflection of the beams are important in order to find out what is the way beam will bend because of the application of the loads. So, for measuring, especially for measuring the weight of a structure and how it affects the supporting beams, when the load is acting, then the deflection is high. It leads to catastrophic failure. So, in order to avoid the maximum deflections for particular loads, that means the beam should have more strength. Section modulus of the beam should be high for a particular loads, so that in order to find out or observe the measure the weight of a structure, how it affects the supporting beams. So it is necessary to find out the deflections. Now, further explanation that a beam is necessary to ensure the structure of a building floors, and too much movement can affect the overall structural integrity of the building. For a static loads, the deflection is the static deflection. For dynamic loads or cyclic loads, it leads to the catastrophic failure and affects the structural integrity of the building. So further, the more the cyclic loading causes the vibrations, the natural frequency, when these vibrations, the operating frequencies are unequal or closer functioning with the natural frequency of the structure, it causes the resonance phenomenon. The maximum displacements will be occurred. So to avoid the catastrophic failures, these deflections for static loads, the deflections are important. For dynamic loads, the deflections are important, and also for static loads. Now, what are the types of deflection? There are various deflections are there. In axial deflection, axial deformation, that is known as axial deflection. Another one is lateral deflection. Third one is angular, and fourth one is combined deflection, and fifth one is the torsional deflections. These are the main. There are other types of deflections also there, but here the axial deflection, when axial load occurs, then axial deflection, also known as the longitudinal deflection. Axial deflection is also known as the longitudinal deflection. Longitudinal deflection. This lateral deflection is known as the transverse deflection. The way we have seen here, the transverse deflection, this is what transverse direction. This deflection is known as the lateral deflection. The angular deflection, because of the angle of twisting movements, the angular deflections will be taking place in angularly. Combined deflection and the torsional deflection. These are the various types of deflections in the field of mechanical engineering or civil engineering, in the specific subject of structural engineering or machine designs. Now, as we have already discussed, what is the slope of a beam? The slope at any distance, is defined as the angle of radiance. In another terms, defined as the angle in radians which the tangent at. So the section makes with the original axis of the beam. At the section makes with the original axis of the beam. So that's what we have studied. When it is deflection, the original axis and the deflection, this angle, tangent at this point. What is the slope at the support? That is theta A. The slope at support B is theta B. The slope at the center, that is theta C, equal to 0. That is when it is for a simply supported beam, when it is subjected to a concentrated load at the center of the beam. So that is if you can understand how the deflection of a simply supported beams we can see, but it is a significantly but in practical the deflection is very small. Okay, the deflection, it is the naked eye we can able to see it, how much it is bent completely. No, but in practical the deflections are in millimeters, in very few millimeters the deflection takes place. Now here in the case of the deflections also takes when it is under when the natural frequency, when the operation frequency, for the case of dynamic loads, when the operating frequency is closer to the natural frequency of the beam, there will be a deflections will be there. Those are known as the mode shapes. Here I am going to show you how the mode shape is. Instead of straight, here the deflection took place. Is a cantilever beam fixed at one end. Okay, so those are known as mode shapes. Deformations takes place at different natural frequencies. So there are various methods are there for calculating in order to calculate the deflection and slopes. The slope is denoted by theta. The slope is denoted with the theta, and the deflections are denoted by y. Okay, and the maximum deflection is denoted by delta or y maximum value. Okay, so there are various methods are there in order to calculate different deflections. In order to calculate the different deflection values, there are various methods are there. In order to calculate the deflection slopes, number one is the double integration method. Number two is Macaulay's method. And the third one is moment area method. These are the various methods to calculate the slope and deflections, of various beams. The beams can be single concentrated loads and multiple concentrated loads, or combination of uniformly distributed load with concentrated load. It can become cantilever beam, or it can be a simply supported beam, or can be a overhanging beam. So how to find out the slope and deflections? And there are one more method also there, that's called conjugate method. This moment area method is also known as Morse method. MOHRS. Morse method. Okay, and there each method is having their own advantages and disadvantages. For particular application, lot of advantages are there. This double integration method is highly useful when only one concentrated load acts. Macaulay's method is useful for uniformly distributed loads and also multiple concentrated loads. Whereas moment area method is related to the bending moment diagram comes in terms of triangles and rectangles. Because this moment area method depends upon the area of the bending moment diagram. So if the area of bending moment curve diagram is having filled with triangles and rectangles, it is easy to calculate the area of that bending moment diagram. If it is non-linear curves or cubic polynomial curves comes, then it is more complicated. Like that, each method is having their own limitations. Now, By using all these methods and derived certain formulae, let us see here. It is a cantilever beam, concentrated load at point P. The slope for that is PL square by 2EI, where P is the point load, where L is the length of the beam, 2EI, where E for modulus of elasticity of a material, and I for second moment of area. So this slide shows for a cantilever beam is subjected to uniformly distributed load and also uniformly varying loads, and point load at the free end and the point load at any point at a distance from A from the fixed. So it is A, then what type of? For the case of the deflection is Y, the delta maximum is PLQ by 3EI. Now here, deflection at any length, at any cross section, that is Px square by 6EI times 3L minus X. If X equal to L, if you substitute, that is PL square, 3L minus L, that is 2L, that's why it is PL cube. If we consider 6 cancelled, if X equal to L, if you substitute in this, it comes at the free end, that is the maximum deflection. WL cube by 3EI, PL cube by 3EI. So more we'll discuss in the revision of class of deflection of the beams. So here in this session we covered mostly what are the definitions and terminologies which are related to the deflection of the beams from basics to the end level, to the higher level. So these are the formulae highly important to solve the problems. Exclusively for a cantilever beam, here it is shown. Alright, thank you.
Like, share and subscribe. Hit the bell icon for more updates.